Hi all, this is Alan with Bothell STEM Coach, and today we are continuing on with AP Physics 1 free response questions, and we're starting circuits, which is the last topic typically taught prior to your AP Physics exam. So I have two light bulbs, one rated 30 watts at 120 volts and another rated at 40 watts at 120 volts are arranged in two different circuits. The two bulbs are first connected in parallel to a 120 volt source. So let's draw a picture of that. And we're going to for AP Physics 1, all you model everything as are resistors. So we're going to model the light bulbs as resistors. Now parallel means they have the same voltage across them. They have the same node voltage across it. And then I have a voltage source here that's 120 volts. Okay, there's different pictures for a voltage source. Some people write it like this, but I find that is longer to draw. Okay. Determine the resistance of the bulb rated 30 watts and what the current is in it when it is connected in this circuit. Okay. Determine the resistance of the bulb when the current is connected. Determine the resistance of the bulb rated 30 watts. Well, I mean, there's not a lot you can do here. You're given the power ratings at the voltage. So what that tells you is, in general, the power through a resistor is given times current times voltage. Okay. Now, for this, let's say this is the 30 watt one and this is the 40 watt one. Okay. So we know that it's 30 watts for this one, for example. And the voltage across it, in this configuration, all right, I gotta see what they're getting. It's current times voltage. Now you could solve for, the voltage, and you could solve for the current and then try to find the resistance of it. That's one way to do it. So I'll do it that way. So let's say, so this is I times 120 volts. Because what's the voltage across the resistor? Well, it's connected to a 120 volt resistor here. So I is equal to 30 watts over 120 volts. Now, they're not asking for I. They're asking for the resistance of the bulb. Here you have to recognize that V equals IR is the resistance of them. So R is equal to V over I. And V refers to the voltage across the resistor, which is 120 volts in this case, because at the two nodes across here, it's 120 volts. That's what this voltage source represents, divided by this 30 watts over 120 volts. So if I use my calculator to do that calculation, I get 480 ohms for this one. Okay. 2, the resistance of the bulb rated 40 watts. Well, I do the same thing for the second one, but it's rated at 40 watts instead. Uh, 360 ohms. Now, you might recognize in this calculation, some people learn that for a resistor, there's two other ways you could write power. Power is equal to I squared R, or it's equal to V squared over R, depending on which one you want to do. Now, because I don't know the current necessarily initially in the problem, you could just say, well, R is equal to V squared over P, because I know the voltage across I know the voltage across the resistor there. So it's 120 squared over 30 or 40, depending on which is the same calculation we did down here. Okay, the bulbs are now connected in series with each other in a 120 volt source. Series means the difference between series. Parallel means the voltages are the same across both resistors. Like this endpoint and this endpoint are the same points across. So the resistors see the same voltage across them. In series, the current is the same. It's not the voltage that's the same. It's the current that's the same. That means current that flows through this resistor also flows through this resistor. And we know already that the 30 watt one is 480 ohms and this one is 360 ohms. Determine the resistance of the bulb rated 30 watts and the current when it is connected in this circuit. Well, the resistance doesn't change, okay? Because, yeah, the resistance doesn't change just because I configure them separately. Yeah, so these are the exact same. So this is 480 ohms, and this is 360 ohms. You do the exact same calculations because it has nothing to do with the configuration. It has simply to do with this rating. Okay. In the spaces below, number the bulbs in each situation described in order of their brightness. Now the question is which one has more power? Okay. See, in the parallel one, because they're doing the same voltage, they both are using the full power. This is 30 watts. This is 40 watts. Okay. Because that's sort of the assumption here. But the difference is here is I don't know that the voltage is 120 volts across here. It's definitely less than 120 volts. Right? So the V squared over R is going to be smaller between this and this. But you actually have to calculate what the current is to determine what. So the way I would do this circuit is I would calculate the current, the total current. The way you can do the total current is I know that 120 volts goes across these two resistors in series. Like this is a 120 volt drop. And the total resistance is 840 ohms. So I know the current would be the voltage, V over R, in this case it'd be 120 volts, divided by the total resistance here, which would be 840 ohms. Okay, so that's 1/7 of an amp. Okay, but I don't need to know that. I just need to know what the power is. And then you could say power, you could use this equation, I squared R, for power, because now I know the current through them. See, I can't use 120 volts because I need, in order to use like a voltage equation or I times V, I need to know what this voltage is and what this voltage is, which is not immediately obvious. Like the voltage here is somewhere between 120 and like 0, right? All I know is that this drops 120, but this drops less than 120 and so is this one. But I don't know exactly how the breakdown is. So that's why I'm going to use I squared R, because I know the current through the resistor. And so this is 1/7 of an amp squared times the resistance, the 480 ohm, for example. And I get this is 9.8 watts. And then the other one times 360 ohm. It's 360 divided by 49. Oops, 49. And that's 7.3 watts. Okay. So the in order of brightest, more power is brightest basically. So this is the brightest. This is the next brightest. Then the series circuit, the 30 watt one is brighter. Yeah, this is 3 and this is 4. Okay. Calculate the total power dissipated by the two bulbs in each of the following cases: the parallel circuit and the series circuit. Well, the total power in this one is 70 watts because it's the power from this one and the power in this one, and that's the total one. For the series circuit, it's the sum of these two powers. So what is that? 9.8 plus 7.3, that's 17.1 out. So in this configuration, they're dimmer, but it also uses less power. And that kind of makes sense. That's consistent with our answer. Our answer is those two are dimmer than the other two, this configuration, and they must use less power for that reason. So hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.